Okay, so welcome back. So in the previous problem, we learned how to rearrange the element using the two pointers. Okay. Now let's take that idea one level deeper. So instead of moving zeros, we are going to compress the data. What we are going to do? Compress the data. Okay. So this is a very common real world problem. If imagine you are having logs or some user data or sorted records and you want to remove the duplicates in place. So we are making the less size of that particular data, right? So you have to remove the duplicate data from that, and this should happen in place. So remove duplicates from the sorted array and no extra space. Okay, so what is the problem statement now? So problem statement is says that you are having one input, it is having some data, randomly data I am writing. So your output that is expected so it should return like unique number of elements, like total 4 elements are there, rest places as the space. So we are given a sorted array and we need to remove the duplicates. We need to keep only unique elements in that array, and you have to do it in place operation, and you have to return the count of unique elements. So what to observe here now? Here is the most important observation, that array is sorted. Okay, in a sorted array, duplicates are always next to each other. This is the points that you can extract from this particular word. If something is sorted, so that is for sure the duplicate elements is always together. So let me this was the element that I have drawn above. So in this you see the duplicate elements are always together, right? So let me summarize the problem now. So instead of removing the duplicates, keep only first occurrence of each element. Instead of removing duplicates, you have to keep only first occurrence of the element. Alright, so we are compressing the array. We are not going to do this like, okay, these two elements, let pick one, these two elements, let pick one. No, whatever the first occurrence, after that I am not going to touch one. What are the first occurrence of this I am going to copy, and rest I am going to ignore unless it is the same, right? Okay, so if I don't care about the space, so what I can do, I can create a new array and copy only unique element, right? So use new array, you are taking one extra space here, then copy the unique element, right, and return the size. But again, the same point that we discussed in the last video, it's going to take extra space because we are creating the new array, and this is not allowed in the interview because they're asking it should be in memory, in place. So let's think now. So we need here one pointers to scan the element. that is for sure. And second pointer is going to place the unique element, correct? Means right pointer will scan and left pointer will maintain the position of the last unique element. Understood the problem? Let me write here. So here is the left, here is the right. So right is going to scan, left will point to the last position, left pointer will maintain the position of the last unique element. Alright, so this is this and will take care. So again we got the 2 pointers here, one to scan and one to maintain the last position of the last unique element. Okay, so let's do some dry run to understand this concept. So we are having this data, sorted array, right? So what should the step 1? I'm going to define the array. So in this case 1, 1, 2, 2, 3, 3, 4. So my left and right pointers are scanning, are pointing to the same element. First element is always unique. Okay, so left is always start at 0, because whatever you're going to save after this element, because left is going to maintain the last unique position, last position of the unique element. Okay, so now coming to step 2. So in step 2, what I'm going to do here, our R is at now index 1. Okay, let me write here index also. So right is just scanning, so when you're going to the next element, so write it index 1, and value is having index is 1, right? Compare with the, now you have to compare this with the left element. So what we're having in the left element, so left is already having 1. So when you're going to compare with your element like left, so what is showing? It is 1. So same value, right? So it's the same value, it means it's a duplicate. So I'm going to simply ignore, right? So left, I'm not going to change anything in the left position. Now if I come to the step 3, now right index will become 2, and in the 2 position I am having the value 2, right? And if I am going to compare with left again, the left is 1. Now it's not same, right? It's a different. So it's a uniqueness is maintained. So I found the new unique elements. I'm going to update something. What I'm going to do, first I will move the left forward. So left will become now index 1, and I'm going to place 2 over there. So my array will become okay. So what I've done here, when I found the new unique element, I'm simply going to left forward towards index 1 and place 2 over there. Okay, so earlier, so see, I found the 2, it means 2 should come here in place of 1. Now 1 is gone, we are not going to maintain this one. Okay, so now coming to the next step, again I'm going to move R to the next index, that is 3, and if you find out the value is 2, right? And if you compare with the left element, left is pointing now here, right? Right, let me see the question again. Okay, 2 will come here, so value is 2 now. So left is going to point the 2, and this is same. So again I'm going to ignore. Now coming to step 5. So in step 5, I move R to 4 now, and if I see the value is 3 now. Alright, so value is 3 now, is now new element because it's not matching with the R, not matching with the left element. Okay, so what this will become now, 2. So left was there, so what I'm going to do, I'm going to place the new element in the left. I will first move the left to with 1, and I'm going to replace. Left will come now here, right? And I'm going to place the 3 over there. So 1 2 3 2 3 3 4, correct? My left is now here. Let go to the step 6 now. So what will happen now? I'll move to 5. 0 1 2 3 4 5 6. R is here, right? Earlier R was here, now R is moving to 5 index. So 5 is 3. Both are same, ignore. Correct? Nothing is changed. Now move to S7. So now R will become here. So what will happen now? 4. Value is 4, and again new element I found. Right? So I'm going to increment the left pointer. So left will come here now, and I'm going to place this value. So my element will become 1, 2, 3. Now 4 will come here, and then 3, 3, 4. Right? And left will be here, and right will be here. Correct? So array is over, loop is broken. Now what I'm going to do, so from 0 to L is the actual unique element, correct? And after this left position, everything should be blank. So the final array will be like 1, 2, 3, 4, underscore space, right? So this is the answer. I mean, this is not the answer. I am looking for the size of this. So I have to return the what? You have to return the position of this, left array. So that is nothing but 0, 1, 2, 3. So size will be 4. Okay. So this is the answer. So if you notice something, we are not deleting the element. We are overriding the duplicates, right? We are not deleting the element. Whatever it is coming, we are going to write over there. Simply override. So this is in place compression. Okay. So if I write the pseudocode for this, so of course left equal to 0, and in the for loop, start from right, and we have to go from 1 to like n-1, right? And if your nums right is not equal to your input data left is not equal to, it means it's a unique element. So I'm going to first left plus plus, I'm going to increment the left, then I'm going to place the value. Nums left equal to nums right. Hope this makes sense, right? And once this is done, then I'm going to return either array size or left plus 1. Okay. So this is what we are doing. So this is the pseudocode. And this very clean logic. We don't have any extra space, and we are doing this everything in a one pass. Okay. So since the question was asking the size, so we are doing this. But if suppose they are saying, okay, print the array, then whatever, it's maybe one variation of this problem. So whatever you do, after left, you just remove everything. Just keep the place. Size will be the same, but this you are going to remove these elements. So this will become, the answer will be like that if someone is asking the array. Okay, so this is the one problem. It is one step deeper than the previous one. Okay, so hope you understand the concept what you are going to do here. So left pointer tracks the last unique element, right pointer scan the whole array, and whenever you are finding a new unique element, we move the left pointer forward, and we are going to place it there or override over there. Okay, so time complexity will be of course order of n, because one loop is going on, and space is order of 1 because we are not using any extra space. We are doing everything in the same array, right? So single pass, no extra memory, optimal solution, right? So if you compare this with the previous problem, earlier what we were doing, we are partitioning, now we are compressing. So two patterns you find, right? In the first problem we are partitioning, I told you, and in this current problem we are compressing, right? So the pattern here is same direction, 2 pointer, 1 scan, 1 write. Okay, so this is a very common interview problem, and we'll see this again in many variations. Okay, so let's see you in the next one. We are going to write this code actually in the in the same pattern in the IDE. I'll show you how to write that.